Equilibrium of a particle. When net external force and external torque acting on a particle is zero, the particle is said to be in equilibrium. If net external force acting on the particle is zero, the particle is said to be in translational equilibrium. And if net external torque acting on a particle is equal to zero, the particle is said to be rotational equilibrium. Here we will discuss about translational equilibrium. First we consider the equilibrium under two concurrent forces. Concurrent means two forces meeting at a common point. Consider two forces F1 and F2 act on a particle. Suppose this is a particle and F1 and F2 two forces acting on this particle. For translational equilibrium, force F1 must be equal to minus of force F2. That is, the two forces on the particle must be equal and opposite. Now we will consider the equilibrium under three concurrent forces or three forces meeting at a common point. Consider three concurrent forces F1, F2 and F3. If the vector sum of the three forces will be zero, then the three concurrent forces will be in equilibrium. Mathematically you can write F1 plus F2 plus F3 vector sum is equal to 0. We can show the vector sum by this geometry. Suppose you have two forces F1 and F2. The resultant of the forces F1 and F2 will be R1. Applying parallelogram law of vector addition, the resultant of F2 and F1 is R1. And for the three forces F1, F2 and F3 to be in equilibrium, this resultant force R1 must be equal to minus of the force F3. That is, R1 must be equal to minus of F3. Remember, for the three forces F1, F2 and F3 to be in equilibrium, the sum of the respective vector components must be 0. The x component of the vectors F1, F2 and F3, addition of this x component must be equal to 0. Similarly, addition of the y component must be equal to 0 and addition of the z component must be equal to 0. In general, if a particle is in equilibrium under the action of the n number of forces like F1, F2, F3 up to Fn, then how you can say that the particle acting upon by these forces will be in equilibrium if they can be represented by the sides of a closed n-side polygon with arrows directed in the same sense. Okay, if these n number of forces are represented by the sides of a closed n-side polygon with arrows directed in the same sense, then we say that the particle is in equilibrium. For example, suppose this is a polygon and this polygon have 1, 2, 3, 4, 5, 6, 7, 8 sides, and these are the open sides F1, F2, F3, F4, F5, F6, F7. These 7 sides are suppose the open sides, and 7 forces are represented by the open sides of this polygon, and they are represented in same sense. That means either in clockwise or anti-clockwise, and they are here represented, the 7 forces here are represented in anti-clockwise direction. Then the resultant of these 7 forces will be along the closed side, because the resultant of F1 and F2 will be represented by the third side, that is R1. Similarly, the resultant of R1 and F3 will be R2. Resultant of R3 and R4 will be equal to R2 and R4 will be equal to R3, like this. In this way, by using the triangle law of vector addition, you can find out the resultant of all these vectors that is equal to here R6. In the next video we will discuss about some problem on equilibrium of a particle. Thank you.